Hello, Accelerated Math 7-8 students. We are working in Module 14, and this is Lesson 8. Lesson 8 is called Linear Equations in Disguise. So let's take a look at the notes that we have here, and I'm going to zoom in a little bit so that you have a better time seeing it. So let me make this bigger. Perfect. All right, that's too big. Okay, linear equations in disguise. Our goal for today. Today we will learn how to solve equations that are not obviously linear equations. So far we've been working with linear equations that pretty much look a certain way, and as soon as you see them, you're able to check the variable to see what the exponent looks like. Then you obviously are able to decide that it is linear versus not linear. And so today we're going to have equations given to us that don't look like the same format that we're used to. So the thing I want you to be thinking about, the question that I want you to be thinking about is, how do you solve an equation that is built out of fractions on both sides? Okay, and the perfect way to get started on this is to practice, and there is one right in front of us right here. If you take a look at this let's review problem, and let me see if I can zoom in a little bit more. That's the wrong way. Okay, now you should be able to see it better and almost the paper. All right, so let's review what we're talking about with that question. This equation, and we know it's an equation because we have an expression that is supposed to equal another expression over here. And a lot of you, when you see this problem, you're looking at it as it must be an equivalent fraction situation. And to look at it like this, some of you may already be thinking inside your mind of, well, I have no idea what divided by 5 would be equal to 6 divided by 12. And so I don't know about some of you, but some of you might be going, okay, common denominators, trying to figure out, okay, how can I make 5 into 12? How can I make 12 into 5? What do they have in common? 60, and figuring out all of that kind of stuff, because that's normally what our brain does. First thing that I want you to do, though, is I want you to pause for just a minute, and I want you to think about, is this a linear equation? Okay, and so we've got to figure out, is it linear, first of all, to begin with? Because right now we're saying that x is a number that is divided by 5 that is equal to 6/12. Okay, and so we have to figure out what in the world is a number that would be equal, or that could be divided by 5 that equals 6/12. Okay, and so I'm thinking, by looking at this, to determine if it's a linear equation or not, we know, looking at this x, that this x right here has an exponent of 1 because it doesn't have any other exponents. So that tells us that it has to be linear. The x is not in the denominator, so we know that the exponent has to be positive, because the only time that the x would be in the denominator would mean that the exponent was negative. And so I'm pretty sure we can be pretty clear that this is a linear equation. So then the next step is to ask you, how do you solve it? So the thing that I want you to be thinking about on this is, we can use a BU chart with this the same way we have in the past. And so what you ask yourself is, okay, let's build it, and then let's undo it, and that will tell us how to solve it. So again, what is our variable? Our variable is x. What did we do to the variable first? What mathematical operation did we do to the variable first? We divided it by 5. So to undo that, we're going to multiply it by 5, and then we will have x. Remembering that because this is an equation, whatever we do to the left side of the equation, we have to do to the right side of the equation. So let's go ahead and try it. So we have x divided by 5 equals 6/12. So the first thing on the build and undo chart that it tells me to do is that I need to multiply this entire number by 5. And when I do that, because this is a fraction, I can write that, because I need to turn this into a fraction, and then I have to remember what I do to one side, I have to do to the other. Okay, and now let's solve it. So we have 5 times x is 5x, divided by 1 times 5 is 5. Then we can simplify this out, because 5 divided by 5 gives us 1, and 1 times x leaves us with x. So now x is by itself. And so we can keep going. All right, so now I look over here and I do the same process and I say, okay, 6 times 5 is 30, 12 times 1 is 12. And so what our answer comes out to being is 30 twelfths. So now let's plug that in and see if it works. So if you take 30 twelfths and you divide it by 5, you should get an answer of 6 twelfths, is what it's saying. Okay, so let's try it. If we take 30 twelfths and we divide it by 5, dividing by 5 is the same thing as multiplying by 1/5. So if we multiply this 30 twelfths by 1/5, it looks a little bit different. 30 twelfths divided by 5 is the same thing as multiplying by 30 twelfths times 1/5. So I would have 30 60ths equals 6 twelfths. Does that work? Well, let's simplify this. 30 goes into 30 once. 30 goes into 60 twice. 6 goes into 6 once. 6 goes into 12 twice. So now it says that 1/2 is equal to 1/2. So the question is, did we do it correctly? And the answer is yes, because you balanced your equation. They equal the same on both sides. So we have 30 60ths equals 6 twelfths, and we know that is true because 30 60ths simplifies to 1/2, 6 twelfths simplifies to 1/2. So we now can say that x does have to equal 30 twelfths. You could simplify it here too if you wanted to. You could say that x equals 15 sixths if you want, right? And then do the same process, or just leave it as is. So we know that x is 30 twelfths. And when we plugged it in over here, we were able to balance the equation. So the thing that I want you to remember that is so important with this whole process is the left side always has to match the right side. They have to be balanced. They have to be equal. They have to be the same. And so by figuring out that x equals 30 twelfths, then we plugged it back in to check it. And we know that 30 twelfths divided by 5 is the same thing as 30 twelfths times 1/5. 30 twelfths times 1/5 is really 30 60ths, and 30 60ths reduces to 1/2, and 6 twelfths reduces to 1/2. So therefore, our equation is balanced. Okay? So that's how you figure it out. Is it a linear equation? Yes, because there's one value for x. Okay? How do we solve it? Just this whole process, using the BU chart and then remembering to plug it back in to double check to see if they are balanced. That last step is crucial. You have to show that they are balanced when you're done. Okay? All right, so let's try this one then. It says, and it's, again, I keep zooming in and out so you can see, and then I run out of space to show you. So let's try the next one. It says x minus 1 divided by 2 is equal to x plus 1/3 divided by 4. Okay, well that looks pretty scary, all right? But the first thing that I want you to do is I want you to think about whether the equation is linear or not. Because if it's linear, then we're able to solve it. So we have to go back over here and think. Our variable is in the numerator, not in the denominator, so the exponent cannot be negative. And right here, it looks like this exponent is an exponent of 1 because it doesn't have any other exponent attached to it. So we know that this must be linear. Okay, so now the question is, how do we solve it? So the BU chart works. I know that some of you really don't love it, but if you can identify what is happening, then you can figure things out. The first thing that I would like to do, however, before we do the BU chart, is I would like to get rid of or take out this fraction on this side. And if I take out the fraction on this side, I would also like to take out the fraction on this side. And the reason for doing that is because if we can eliminate the fraction, then everything else is going to be a lot easier to figure out because we have to combine like terms because there's x's on both sides of the equation. And in order to solve for x, all of your x's have to be on the same side. And so I would like to eliminate the worry of the fraction. So the way that we can go about doing that is right now we have x minus 1 divided by 2. In order to take this out of a fraction, you need to undo what it says. So let's only focus on the left-hand side for just a minute. Read it as a division problem. X minus 1 divided by 2. So in order to not divide by 2, what could we do? You could multiply by the reciprocal, yes? So if we take x minus 1 divided by 2 and we multiply it by 2 over 1, let's see what happens. Are you ready? So we have 2 times all of this, right? And then we have 1 times this. But the thing that we know is that if we have 2 times all of this, right, divided by 2, then we can now, before we have to distribute it out, we can simplify the 2's. So 2 divided by 2 is 1, and 2 divided by 2 is 1, so I'm left with 1. What is 1 times x minus 1? X minus 1 divided by 1 is x minus 1. So when we multiply this by the reciprocal, basically what we're doing is we're taking that 2 out, okay? But if we do that, what you do to one side, you have to do to the other. So in order to get this to work over here, remember, I'm changing the value of this, so I now have to change the value of this. So let's take a look at what would happen over here. So on the left-hand side now, because we've taken it out of the fraction, what we have left is we are left with x minus 1 on this side. But remember, in order to do this, what you do to one side of your equation, because you changed it, you have to balance the other side of the equation and do the same thing. So now I'm going to take x plus 1/3 divided by 4, and I have to take all of that and multiply it by 2 over 1. Okay, oh, you can't even see it, so let me move over here. All right, so I have to take all of this and I have to multiply it by 2 over 1, because what you do to one side, you have to do to the other. All right, so now if we're looking at this, we have this up here is equal to 2 times x plus 1/3, right, divided by 4 times 1, which is 4, right? So then, just like we did over here, we can simplify out the 2. So 2 divided by 2 is 1. 4 divided by 2 is 2. And now, on this side, we're left with x plus 1/3, because 1 times x plus 1/3 is that, all divided by 2. So now we have that. Okay, does everybody see what we're doing? All right, so now this is our new equation. But some of you are still saying, okay, Mrs. Nelson, that's great, but we still have a fraction. So how do we get rid of this fraction? Okay, not hard. We're going to use the same process we did over here on the other side. Is on the left-hand side of the equation, we have x minus 1 equals x plus 1/3 divided by 2. So we're trying to get rid of this denominator. Can't see it, sorry. So what I have to do is multiply it by, because right now this is in the denominator, so I'm going to multiply it by 2. So when I do that, remember what happened. If you have this little thing right here, it really looks like x plus 1/3 times 2, right, over 2 times 1. Yeah? And so 2 times 1 is 2, and we're not going to distribute that out because we're going to simplify the 2's. So they're all to 1's now. So x plus 1/3 times 1 is x plus 1/3. 1 times 1 is 1. X plus 1/3 divided by 1 is x plus 1/3. So we're left with, on the right side this time, x plus 1/3. Now, what you do to one side, you have to do to the other, so we're going to multiply this by 2 over 1. Well, that's pretty easy. What is 2 times x? 2x. What is 2 times, or 2 times 1, and then we subtract them, so we get minus 2. And then all of that is divided by 1. Well, 2x minus 2 divided by 1 is still 2x minus 2. So now, as a very, very long process, and as you can see, running out of space, we have this. And so I'm going to show you that last step. The last step of this is to solve the equation that we have left. And what I want to do is, let me see if I have the back side of this paper. Yeah, let's just go to the back side really quick. So I have 2x minus 2, 2x minus 2, can you see it? No, of course you can't. 2x minus 2 equals x plus 1/3. That's what we're left with now, okay? So now, I know, it's a big process. You want to get all of your x's on one side. So on this side, visually, you have 2 x's, and then you have plus 2 negatives. So if we want to write it, it would look like this. 2 x's, and then we'd have 2 negative chips. That's what we have on this side. On this side, we have 1x, and we have 1/3 of a positive chip. So here's our chips, and you only have 1/3 of it. So you have this, and it's positive. Okay? All right, so that's what we have visually. So what we want to do is we want to get all of our x's on the same side. So do you want to bring these 2 x's over here and make them negative, or do you want to make this one negative and move it over there? For me, I always like to go with the smallest amount, so I'm going to subtract x from this side, creating a 0 pair, and then I have to bring it over here and subtract x, because what you do to one side, you have to do to the other. So now I'm left with this positive x and this negative cancel each other, so I'm left with x, and then minus 2 equals 1/3. That's what I have. Okay. Now we can use our BU chart. It took a long time to get there, but we can use our BU chart now. So we have x is our variable. We're subtracting 2, so we're going to add 2, and we're going to be left with x. So let's add 2 to this side. What you do to one side, you have to do to the other. And so x plus 0 is x. 2 plus 1/3 is 2 1/3. So now we have found that x equals 2 1/3. So then I told you at the very beginning, you have to substitute it back in. So this is our original problem. X minus 1 divided by 2 equals x plus 1/3 divided by 4. So now we know what x is. So wherever there is an x, you have to substitute what you have. So this is really 7/3 minus 1 divided by 2 equals 7/3 plus 1/3 divided by 4. Okay, and now we're going to simplify that. So if we have 7/3, take away 1, well, we know that 1 actually equals 3/3. So 7/3 minus 3/3 is 4/3, and all of that is divided by 2 equals 7/3 plus 1/3 is 8/3 divided by 4. Okay, you guys are probably going, oh, Mrs. Nelson, you're crazy. Well, I'm really not, because this totally is doable. So remember, this is a compound fraction, so you're just going to multiply by the reciprocal. What you do to one side, you have to do to the other. So what we have on this side is 4/6 divided by 1. Now let's try this side. So we're going to multiply by the reciprocal on both sides, right? And so we get 8/12 over here divided by 1. What does this simplify to? If we divide this by 4 and this by 4, we get 2/3. And then if we divide this by 2 and this by 2, we get 2/3. So does our equation balance? 2/3 equals 2/3, and you did it. Okay? So wow, holy moly, that's a whole entire piece of paper that we had to use for that one problem. However, if we go back, were we able to solve it? Yes. Okay? And so something as ugly as this one, it is solvable because, come on, Zoom, not working now. There we go. Something as ugly as that yucky thing is solvable because we figured out that x has to equal 2 1/3. And when we did that, we showed that they were balanced. Okay? All right, that was a lot. And I know you guys are like, oh my gosh, she's nuts. But this is it, guys. This is hard math that we're working into. Okay, something that I want you to remember really quickly is that 5/12 is equal to x 6ths is the same, can be written as multiplying it by the reciprocal. So we would know that the reciprocal of this would be 6 x's. So when you multiply this, let's do it over here. 5/12, let me move it so you can see it. 5/12 is equal to x 6ths. So in order to get that, we could multiply by the reciprocal. So the reciprocal of that one is 6x's. So what you do to one side, you have to do to the other. And so look at what we have. We have 5 times 6, which is right here, is equal to 12 times x, which is right here. Okay? And so that's a little thing to help you. This is also a side note right here. As long as the denominator is not 0, then you can multiply the numerator with the other denominator, as long as it's not 0. That's something to help you with, so that you have this big old conglomerate of work. Sometimes that can be helpful. All right. I know you're completely overwhelmed, but I believe in you, and I think that you can do this. So our goal for today. Today we will learn how to solve equations that are not obviously linear equations. We just proved that, right? And then the question is, how do you solve an equation that is built out of fractions on both sides? Number one answer to that is, remember, multiply by the reciprocal. What do you need to do? Multiply by the reciprocal. All right, kiddos, that's all I have for you. Really long video, but I think you can do it. Talk to you soon. Bye.